Good morning. We'll be starting in about 2 minutes. And we'll do an experiment about the weather. I'll explain. A little over a minute, and we're going to get started. You want to go ahead and open up your pods, and your chat pod, your Q&A pod, and get ready to answer polls on pollyv.com. If you open up your chat pod, you get links. And if you notice in the chat pod, if you cannot see the handout, then you can email Amanda and she'll email it to you, or just even our general email address. Okay, we'll give folks about 30 seconds to finish logging in, and then we will get started. Okay, good morning and welcome. My name's David Orr. I'm the director here with the Cornell Local Roads Program. We're your New York State LTAP Center. And today's foundational webinar is on gravel and base materials. It's part of our summer series of 11 total webinars that we're doing. You can see we're up to number 4. We'll be running these all the way until the middle of August. So now, if you haven't been on one of these webinars before, there's 4 things to just remind you of. One, the audio settings in the lower left corner. If you've got sound issues, we do ask you to just to help out yourself. In fact, you might want to go ahead and open up your chat pod. That is a one-way. We'll send things to you, so you don't have to write down the links for the handout or links for the polls or things like that. If you do want to send us questions, open up the Q&A pod, and we'll be looking at those answers in the Q&A pod. Plus, if you can't access the Poll EV polls, you can put your answers there. And I will be asking you to raise your hand using the raise hand feature a couple of times during the course of our time together. Okay. So let's go ahead and get started. If you're wondering, there is a professional development hour for this particular webinar. Only the person registered, and it does count as a course in New York State's rules, though that's not as critical as it used to be for getting your continuing education. If you're from outside New York State, you'll need to check with your LTAP center to see what the rules are in your particular state. Okay. Now, let's do a little bit of a welcome. This helps me see who's on the call and allows me to make some minor changes based on what you tell me. And see what your answers are. So we're going to be using pollyv.com/DavidOrPE. Okay. So the first one I like to know is, who do you work for? Town, county, city or village, state or federal, tribal, an MPO, an authority like the Thruway Authority. You're a consulting engineer, you're a contractor, or you're just working for a living. So today we actually have a nice variety. I like it. We have state and fed, we have cities and villages, towns, counties, contractor even. That's good. I like it. Good variety today. And quite a few who are working for a living. Okay. What do you do for those agencies? Are you an administrator? Are you the deputy or highway superintendent or the commissioner? In other words, you're supposed to be in charge. Are you the engineer? You in the field crew? You're a board member? Or if you're none of the above. I don't mind if you do none of the above, but if you do that, throw that into the Q&A, what you can do. And by the way, you can access the poll via the web. You don't have to have the app on your phone. You can just do it via the web if you prefer. But again, you can always put the answers in there. So we have mostly engineers. It's not what I'm not surprised by that, but quite a variety of folks for the remainder. Okay. And again, if you do ever do a none of the above, put in the Q&A what the none of the above stands for. How long have you been there? Well, actually, let's say current position. I've been promoted, like to know that too, but is it less than a year, all the way up to 20 plus years, just to get a sense? Oh, we got a few who've only been in their jobs for just under 3 months. That's interesting. Okay. Wow, good variety. Well, my goal today is to help you pick up something, to pick up one thing to take it home when it comes to gravel and base materials. And I think we'll be able to do that for everybody here. Now, what I'd like to know is where you are in New York State, but if you're from outside New York State, you can click on the map somewhere else. But let's see what we have. We have downstate, we have Long Island. Oh, we have a Canadian friend today. Okay. So quite a variety. Interesting. Not many in the southern tier today. Okay. Okay, so let's answer a question. We've asked this question before, but it's always a useful one. And, why do we build roads and streets? I'm just curious. It's just why do you think we build roads and streets? We can talk about this for lots of classes, including safety classes that you put in. Yes, there is a handout today that if you've got your chat pod open, we'll send you a link to the handout. And while we're letting people put their answers in, I will quickly show that for just a second. If it pops up, no, it's not popping up because of the poll. I'll show it after the poll. Um, but there's a handout. Main thing there's resources and an outline, but I'll show you that after we do the poll. But yeah, we move people and goods, we move transportation. It helps our communities. There's lots of reasons we build roads and streets. And I like to think of it this way when it's a picture of my mom, my uncle, and their mother, my grandmother, sitting on the porch on Arnwood Avenue in Macon, Georgia. So, okay, let me just show you quickly the handout. Again, it has an outline, a few key points, and then really main thing is some resources that are available and the list of the rest of the webinars for the summer. Okay, so why we build roads and streets, I think we can all agree upon. But really, when we think about it, we've said this before, roads and streets really, you have to think about the traffic on the road, the structure of the road, and the geometry. Okay. Now, we're not going to talk much about the geometric alignment today. We might talk a little bit about width, but really, mainly, we're going to be talking about the traffic and the structure that goes on that roadway. Because, as one of our former circuit riders at Kearney used to say, you need to build the road to handle the load. And a lot of that comes from the material that we are talking about today, base and gravel materials, because roads actually do have a structure to them, ranging from the surface all the way down to the native material that we build on, the subgrade, i.e. the material after we've stripped off the organics. Okay? And there are different definitions for what people use. I want to make sure we're all on the same page. So just let me ask you this. This is a picture here in the city of Ithaca where they had milled off the surface. So they were getting ready to repave after they had ripped off all of the asphalt. There's no asphalt left. If you've done that on your roadway, you've got this material exposed. What do you call that material? What is the name you use for the unbound material under the surface? Okay. So let's see. Sub-base. Okay. Base. Depends how thick your road is, what you call that. It might be a base, it might be a sub-base. Some bases are bound materials. Okay. Anybody use other terms that are more specific? Um, I can tell I'm talking with more engineers because of the answers you're giving. Some people say the term gravel. Okay. You might hear the term crusher run, bank material, lots of different words people use for it. Okay. Now, some people, the surface of the roadway is unpaved. Okay. So I told you I'm going to ask you to raise your hand. Raise your hand if you are with an agency and you have unpaved roadways, gravel or earth surfaces, or if you're an engineering firm, you work with those kind of roadways. Just trying to get a sense of how many of you deal with unpaved roadways on a regular basis. And I'm guessing it's not going to be a lot today, but that's okay. Okay. So only a few of you, about 5 or 6 of you have put in there that you're got an unpaved roadway. This, by the way, is the main road in Russia between the capital of Siberia and Moscow. So this would be the equivalent of 5 and 20 before they built the thruway, but it's unpaved. And you can imagine it's not real good in the spring. And no, that's not me. I've had people say, "Is that you?" No, that's not me. It's just a person who happened to be in the picture. These were taken by a colleague who was in the civil engineering department. Okay. Now, we're going to come back to this unpaved road here in a little bit because that's actually pretty important. But let's remind ourselves of what we're trying to do when we build a roadway. Vehicle comes along, truck's doing most of the damage. We know about that. But we're trying to spread the load out so we don't overstress the subgrade. And so we put a pavement on top. Okay? And that spreading the load out means the subgrade is protected, but the pavement then has to pick up some of the forces from the tire. And what we really look at a lot of cases is the deflection of the roadway as it bends, goes up and down as the loads go by. Okay? Now I can illustrate this better with a video. This is video shot by the U.S. Forest Service. You can actually see the pavement move. Watch the two green dots. It makes it a little easier to see. And these are a road designed to fail. This was done by the U.S. Forest Service, as I said. And you can see high water table, a little dirty in terms of the material, a very thin surface. And so it only takes 81 passes of these fully loaded dual tandem trucks to destroy this pavement. Now, if this was your own road, you'd be having a bad day. In this case, it was actually designed well because they wanted it to fail as part of a research project, looking at the effects of materials and water and all that fun stuff. But this is why different people use different terms. If you're on a state highway, okay, on a state highway, you're going to have a series of layers. You're going to have a surface layer, which is, you know, some kind of super pave or it's kin, later kin of massacre and all that fun stuff that are out there, and probably warm mix these days. You're going to call that surface material. You might have a binder layer. You might have a base layer of asphalt, but it's all bound materials before you get to a subbase, which is unbound. Okay. And that subbase is relatively thick. We'll talk about thicknesses in a little bit. And this is the roadway over the top of the subgrade. If you're on a collector road, maybe a county road is a common example of that. In this case, you might have an asphalt layer or two over a base layer, which is unbound. Okay. So in that particular case, the base is actually more critical for the structure. Okay. It's more critical for the structure because it's doing more of the structural capacity work. And of course, if you're on a town road, it might just have a chip seal on it. Okay. And that chip seal might have been placed on an old gravel road. It might have been placed as part of an upgrade, but you can actually have a pretty good road with just a chip sealed surface. And of course, a lot of roads, almost everything but the interstate system, started as unpaved outside of cities. And so in that case, you've just got a gravel surface. And the quality of that gravel, obviously, as you get thinner and thinner surfaces, becomes more and more critical. So when we're looking at that road structure, what we're going to be talking about today is the unbound layer and why that's such a critical layer when it comes to having our roadways last as long as possible. And that might be, again, it might be a base. It could even be a surface. A lot of cases, it's a subbase, but we're talking about that base layer that's over the subgrade. Now, just again, this helps me, but also gets you thinking a little bit, I hope. If I was asking you for your agency, or again, if you're from a consulting firm, the kind of roads you work on the most, what would you say is the most common asphalt thickness? Unpaved roads, less than 2 inches, 2 to 4 inches, 4 to 6 inches, 6 to 8, or greater than 8 inches. Okay, let's see what y'all come up with here. And I'll come get my mouse and scroll down so we can see. And I didn't think we have many unpaved. Okay. So 2 to 4 is the most common. This is the center of our curve, but with quite a few of you have 8 or more inches. And what that means is that asphalt's doing a lot of the work. Okay. Now, if you've got a paved roadway, okay, this is important, paved. So if you look at the bottom left, you'll see the word paved. Okay. If you have a paved roadway, what is the thickness of the gravel layer? Could be a base, it could be a subbase, but this is above the subgrade. This is material that is brought in to make that road stronger? Is it 0 to 6, 6 to 12, 12 to 18, 18 to 24, or greater than 24 inches? And again, let's go see what we've got here. Um, Interesting, nobody put greater than 24 inches, but a lot of you have 18 to 24. 12 to 18 is probably the most starting to build up our bell curve. 6 to 12 and 0 to 6 inches. Okay. Now, if you think about that, let's just say 12 is the middle of the bell curve. Okay, as we're making our shape up. How much does it cost to put in gravel? How much are you paying for gravel these days? Throw that into the Q&A. How much money are you spending these days on gravel? Let's see what y'all come up with. How much money? Again, whether you call it base or sub-base, I'm going to use the term gravel just so we're on the same page. Nobody seems to know. Somebody says not applicable, I'm retired. Good answer. $100 per cubic yard? That seems high. I'm talking the unbound layer. Yeah, you don't know. And that's actually something you need to think about. How much does it cost to put down a gravel layer versus how much for a paved layer? And someone says we don't use it in New York City. New York City, a lot of your roads are gravel, or excuse me, are asphalt, concrete, and then there actually is a layer under there, but that's part of the structure, but something to think about. So I've got a 60. That's a number you need to think about. Where do you want to put your money? What's the value you get in pavement design for that granular layer? And it actually can do a lot of work to protect your roadway, your asphalt layers. Because I'll ask this one, hopefully you know this one. How much are you paying per ton for asphalt layers per ton? How much are you paying? In place, by the way, if you know the number. If you don't, you can do FOB, pick it up at the plant. But how much are you paying for the cost of asphalt? $120 I've got per ton. Okay. See if anybody else wants to say. I know it varies quite a bit around New York State. I got another 120, 110, 175. If you're doing in place, yeah, it could be. But again, these are things that you need to start thinking about because really a lot of this is an economic decision. By the way, what do you think, just because if you think about it a little bit, what do you think the most common gravel thickness on unpaved roads is? Okay. And I'm going to clear the answers because these are the old answers. I'm going to clear them. Okay. What do you think it is for unpaved roads? And again, I know a lot of you don't have gravel roads. You're sort of guessing a little bit, but that's okay. I just want you to start thinking about the structure of the roadway a little bit. And so most people are saying 12 to 18. A few are saying greater than 24. And the reason I want you to think about that is because realize that almost all roads started as gravel roads. And so therefore, yeah, it might not be the best material, but that's what was there. That was the base. It used to be the surface. Now it's the base of the roadway or the subbase. That gravel is still there. If it's been contaminated, that's an issue, but there is a structure in a lot of cases. Okay. Now, the other thing that matters, and again, we won't get into this a lot, but I do just want to touch on it. If I was going to ask you, what is the most common number of vehicles per day on your roadways? The closest 100. Round, please. We're going to build a little Wordle just to see what numbers y'all put in. What is the number? 1,200 vehicles a day? Okay. 1,000, 2,000, 10,000? Yeah. And the reason I wanted you to think about this is way too often we build the same structure for all of our roadways. And yet there's three things that really make a huge difference in how much structure we need to have. One is the number of vehicles per day. If you're on the road going outside the university, New York State Route 366, you're talking 30,000 vehicles a day plus. But if you're on campus, you're only talking maybe 10,000 vehicles a day on the main roads, in some cases under 1,000. You're going to have a different structure. The other thing that matters, and we don't have time to do a lot of this today, but I just want to remind you the truck traffic type matters. Is it trucks? Is it agricultural equipment? Is it just residential vehicles? That can make a huge difference in terms of how much structure you've got to have. And you're going to have different thicknesses to handle the loads to last as long as you want them to last. We do have a tool available. We call it Road PE LHI. The LHI, I set the acronym to stand for Low Volume Highway Inputs. It's actually the initials of our former director, Lynn Howard Irwin. But if you're interested, it's available. It uses a spreadsheet, which means it's probably not as fast as it could be. And I know you're going, the figure's too small, I can't read it. That's okay. I just want you to say there, if you're interested, there's a tool to do modern mechanistic design for pavements that involves a spreadsheet that works up to about 2,000 vehicles a day. It's not really going to work on the higher volume, but you can run the numbers to get you in the ballpark. And the idea behind any pavement design is you first have to check the existing pavement. Whether you're using AASHTO 93, you're using the tool we put together, or using the modern AASHTO ME device, um, you really have to check the existence. And someone says, is it in our camp, our asset management program? It's not. It's a separate link. It's in the handout. Could we integrate them? We'd have to think about that, how that might work. But the idea is you got to check the existing. Because I've seen people, they run a design and they go, oh, we got plenty of structure, not realizing they've already lost a lot of the life of the pavement because pavements fail in fatigue. Then you run your design using whatever's there and decide, hey, do I have to start over? Can I just recycle? Do I have to do a rehab or what do I have to do? And of course, any tool you use should allow you to tweak, just do a single check, and any good tool should have that. If it doesn't, you might want to think about looking at another tool. And we don't do enough design. We should do more. But if you think about it, you probably should be able to, have a tool that can do a design about the time it takes you to wander over, get your coffee cup, and come back. And that's a good rule of thumb. If it's longer than that, it's probably something you're not going to do much. But we do need to design our pavements to handle the loads because there is a road structure involved. Okay. But what I want to make sure we're on the same page on is how do we get that good gravel layer, that subbase, base, whatever we call it. We want to have good gravel. And it can make a huge difference in the life of our roadway if we've got good gravel. You can run the numbers, but it could be a factor of 2 in terms of lifespan by improving the drainage. And part of that means having good gravel. So what's the recipe for good gravel? Well, you need lots of drainage. You've got to be able to drain the material. Okay? You've got to be able to have that. You've got to have the correct mix of gravel, and you're going to have to do some testing, whether you like it or not. Okay? Now, I've got a question over in the Q&A. I like to see questions. It says, how is the issue of very infrequent heavy trucks addressed? A new development residential street only accommodate heavy dump trucks during construction, but not after built out of the development. The way you do that is you account for it in a short-term design, because the cool thing is for pavement design, they fail in fatigue, and you can actually sum up the percentage of pavement loss during the development. There's actually a way to do that if you're interested. Pop us an email. We can send you the link. The link is there in the handout. That's how you would deal with it. You just do a short-term check to see what fatigue life has been lost. The timing matters, by the way. We don't have time in 1 hour together to get into it, but boy, timing makes a huge difference. If you send the same trucks in the middle of spring thaw versus right now when it's pretty dry, or in the winter when it's frozen, you get a very different amount of fatigue lost. But you need good binding material as part of that good gravel in some cases, okay? So let me talk about what makes a good gravel, and I'm going to do this in not an exact order of importance, but a pretty important order of importance, at least for base gravels. You want clean gravel. What that means is you want to have limited number of fines. We'll talk about that in a minute. You want that gravel to be strong. What that means, it can handle traffic. There are tests for this, though you already know probably the gravels in your area, which ones work and which ones can't handle the traffic on them. They break down. You don't want to be building roads out of shale, typically, for instance. You need ones that are durable, can handle freezing and thawing, and there's good test for that. New York State's got a pretty good procedure, and we'll talk about a couple of those tests in just a couple of minutes. I'm going to put one up here that is important for base gravels and sub-base gravels. Is not as critical for your surface gravels. In fact, you actually need a little bit of plasticity. Okay, you need to have a little bit of binder, as was put into the Q&A. Um, you want it to be well graded typically, okay? Not always well graded, okay? There are some open graded mixes that can be put out there, but then they have to be designed to be stable. Normally, we like a well graded, dense, compacted mix, and then angularity. And I put that last mainly because if you asked me all of the others, but I couldn't get angular for a base gravel that's under asphalt, I'll live without an angular material. I can make it work as long as it's not just completely rounded. But if I've got great angular material that's dirty, it doesn't matter. It's still going to have problems. So let's go through the more critical ones here and talk about what that means. So what do I mean by clean? Well, gravel, of course, or base or sub-base, whatever you want to call it, is actually a mixture of particles of different sizes. The gravel-sized particles, the larger things, is where the strength comes from. That's where you're going to have your strength of the roadway. It's got to be durable and handle everything. Then you're going to have some sand in the mix. That sand fills in the voids, still pretty good for drainage. And that's all you need. You don't need anything else. But the reality is, since we're using native materials in the area mostly, you're going to have some fines, like it or not, some silt and clay. Okay? So you're going to have some fines. So what I'm going to show you here is a chart that we've shared. It's on the handout in a different color schema. And what essentially we did, long before I was here, our original director, Jim Spencer, uh, got samples of gravel from every county in New York State. So glacial tills mostly. Not completely, but mostly. And found good gravels and bad gravels, started looking at the features and what makes good gravel, what makes poor gravel. And then over the years, Len Irwin tweaked it a little bit. I've done some tweaking. We've looked at other specs from other places like the Pennsylvania Dirt and Gravel Roads Group and other LTAP centers and other standards like the U.S. Forest Service. And what we found pretty consistently is you need about 50 to 70% gravel. That's where the strength comes from. That's the durability. And in terms of the mix of sizes that you put into the Q&A, you got to have that dense gradation to it. There's a little bit more, but in 1 hour, we can only sort of give you the range. There has to be a range of gravel sizes, up to no more than 3 inches, maybe even a little smaller on a surface gravel, down to sand size, that 1/4 inch cutoff point. Sand, you need about 25 to 40% sand size to fill in the voids, help it pack, and it's still pretty good from a drainage standpoint. That's true wherever it is in the pavement, okay? If you've got too much gravel, it's not as stable. If you have too much sand, you don't have enough strength. So you need that good mix. And then how many fines do you need? Depends where it is in the roadway. Up to about 8% fines, some of the negative effects of those fines that hold water and are soft in the spring don't hurt you so badly. Though I'll be honest with you, the closer you get to the surface, the cleaner you want that material to be. But we'll say up to 8% for most cases. But for a surface roadway, gravel roads, which very few of you said you deal with, you need that binder, as was put in the Q&A earlier. That's 8 to 15%. Okay? So you actually need some binder in there. Silt and clay actually help hold that roadway together. Now, obviously, the type of fines matters, and there's a whole bunch of other factors, but you do need the fines. Now, if your roadway looks like this, you probably did pretty good. Your base is probably pretty clean if you've got good drainage. But the problem is, if you just chip seal or pave over a gravel surface, it's probably in that hash zone. It probably has, just by time and default and what we know works, we've sort of put down by just history, material that's got a fines content that's a little bit too high for having a chip seal on it or having pavement on it. And what happens is water that used to evaporate builds up in spring thaw periods, and we get problems. Okay, so here was a gravel road. It had been gravel for a long time. It got chip sealed and it blew itself apart. Not because of the ditch, not because of the slope, because of the quality of the gravel. The gravel, when it was tested, had a fines content of 13%. Well, at 13%, it held too much water. Okay, as a gravel surface, fairly low traffic, but you chip seal it, you don't clean that gravel up first, you're going to have problems. Okay. And by the way, if you're wondering why the 8%, what we found is about up to about 8%, especially with silts, which are really common in New York State, is not too weak in the spring and it doesn't have frost effects to it too much. This is a good example of what happens in the winter. As it freezes, if it's got a lot of silt, there's water available, the roadway will heave. Okay? Because you know and I know the road stripe was not placed with a dip already in it. Um, Probably paved is probably pretty smooth in the summer, but in the winter, you can find the culvert, it doesn't move. Anything above about 8%, we start to see frost issues, which is one of the reasons, by the way, we are concerned when people are using what everybody likes to use, item 4, which by technically is type 4 from a state spec. That's actually a sub-base material. Okay. But if it's close to the surface, those frost issues can get you in big trouble. So we really want to have relatively clean material if we can. Now, let me just ask, how much gravel testing do you do? Okay. Now, again, I don't know if you want a pit or where do you get your gravel, but your unbound layers, do you never test them? Do you do it once a year? Do you do it as things change? We'll talk about that in a little bit. Do you do a different check the testing for each job? You know, if you're doing a major work, you only use state approved material or other. If you put other, please throw it in the Q&A so I know what you mean. And then while you put your answers in, I'm going to go down here and see what your responses are. Okay. And so most of you are using only state approved material. And if you're using only state approved material, that's good. But I do ask, what is your spec that you're using? Okay. We'll come back to that spec issue in just a little bit because most of the state specs allow for 10% for your gravels, your unbound layers, which means they could have frost issues, especially if they're relatively close to the surface. Okay. We really want to keep it below that 8% fines content. If you're not testing, I worry about that. It's relatively cheap insurance because there used to be a company that made these testing machines that crushed concrete cylinders, and the motto was one that it's worth repeating, and that is one test is worth 1,000 expert opinions. Okay, so you really do some gravel testing. That's pretty important. What test do you do? Well, obviously you're doing a sieve test. Here's a picture of the wash portion of a sieve test, which breaks down the particle sizes. Okay, that's a critical test. We all did that for those of us who went to college and took geotechnical engineering. You all remember your soils class and you did a sieve test. The wash is really important to get that number right. Another test we do is called soundness. Okay, and I'll come back and talk about soundness in a little bit more, but soundness means how does it handle freezing and thawing and freezing and thawing? Okay. The plastic index, and again, we'll talk about this one a little bit more, and that's how plastic this material is. How does it behave in the presence of water? Okay. And there's a test I want to talk about called the sand equivalent, and that's related to the plastic index, and we'll talk about that more. There are other tests, and if we had a whole day, we might talk about other tests, like there's a test to check for durability called the LA Rattler test, where you took the material and you put it in a big dryer and you spin it around with steel balls and see how it breaks down. And that's an important test to do, but you probably know most of the good materials, the things that are going to hold up under traffic. And there's some hand tests you can do to help get you started. But let's look at these four. Actually, we're going to look at three of them. The sieve test is one we all should be doing. We should do that on all of our aggregates, whether they're gravel, base, sub-base, or even asphalt and concrete. We should be doing sieve test. What is the soundness test? Well, if you've got a material that is not sound, what happens is it freezes and thaws, water gets in, and it breaks it apart. And that could be because it's a weak stone, like a shale. Okay. It could also be because it's a conglomerate. It's a material that's only held together by some light cementation. Okay. And it looks okay under the eye and it seems to do okay. But then when it freezes and thaws, it breaks apart. The Catskills are filled with materials with poor soundness. And you could do this with water baths, where you put the rocks in the water, take them out, freeze them, thaw them, put them back in the water, back and forth. It's expensive, it takes longer, takes more energy. And so what they've done is they said, well, we can make crystals. We can make crystals relatively cheaply. And we'll do that with Epsom salts. It's called magnesium sulfate, but the same Epsom salts that your grandmother uses on her feet is the same stuff. We take a saturated bath of Epsom salts, we drop the rocks into it, let it soak, bring it out, and then heat it up. And as you heat it up, the crystals form, the same crystals in the other direction when you freeze it and make it colder. And you'll get a breakdown of the rocks. And it's got to be able to handle a certain number of cycles depending where it is in the pavement. And if it breaks down too much, it's not sound. And that's a test that you should be testing. If you're buying state-approved materials, they're doing that test for you. Okay? The other one is the plasticity index, how plastic it is. And the two parts of this is you make little snakes and see how they compare. When did they break apart? At 1/8 of an inch. That's that little rod you see right there. It's actually a nail with the head cut off. Um, what's the moisture content? That's the point at which it behaves more like a solid than a plastic. Okay. And then you'll make a little groove and you crank it. And again, we could talk about that for a while, but the idea is when does it start to behave like a liquid? And what we care about is the range when it behaves in this sort of plastic state. If it's a silty or sandy material, it goes right from being almost a solid to being almost a liquid immediately. You've all done that when you did a sand castle, where you just a little bit too much water and all of a sudden your sand doesn't hold together. But with clays, that range can be pretty broad. Okay. There are materials in Texas that have been tested and have a moisture content range for when they're plastic of upwards of 400%. And boy, they hold a lot of water. I'm glad we don't have to deal with those kind of materials in New York. And if you're from Texas, you do know about expansive clays. But the plastic index is a great test for when you've got a lot of clays, especially what are called heavy clays. Okay? But I want to introduce you to another test if you don't know about it called the sand equivalent. And do me a favor, raise your hand if you've heard of the sand equivalent test. Raise your hand. Let's see how many of you have heard of it. If you ever dealt with super pave asphalt fault, when it first came out, especially, the sand equivalent was actually one of the tests they did on the aggregate. Okay, so just a few of you. It's a pretty cool test. It's actually one we recommend, and we'll talk about why in just a little bit. And that has to do with the fact that it's essentially an alternative to the plastic index. What you do is you take material in a specific solution that's calcium chloride, and so it causes it to flocculate and some glycerin, and you essentially shake the heck out of it. It's like the old mason jar test that we've probably all run, where you have a mason jar, you put the gravel in it, you shake it with some water and let it sit on a shelf overnight. This is a scientific version of that. And what you do is you shake the stuff that is smaller than the number 4 sieve, i.e. the sand size stuff, and you let it settle out for about 20 minutes. And you measure the height of the column. And what happens is anything that's sand sized and larger is going to fall out immediately. Anything that is finer than that, the silts and the clays, are going to slowly settle. And you actually, timing matters, but you measure the height of the column after 20 minutes of settling. And what you get is a ratio of the portion that is the total height of the column to the portion that will support weight. You actually put a weight on it, okay? And you get a relationship called the sand equivalence. So you take your clay reading, you take your sand reading, the part that will support weight, you do a ratio of those two with the sand being on top, and you get sand over clay. That gives you your sand equivalent, okay? So the sand equivalent reading comes about by doing this test. It takes about 40 minutes total. You can actually do it in the lab and get pretty good results within a couple of points, and you'll get a result. So if I take and get a clay reading of 7.7 and I get a sand reading of 3.2, what's the ratio? Get your little calculators out. I know, I'm going to make you do math. What is 3.2 divided by 7.7? Assume that somebody comes up with in the Q&A. I'm like, he's making me do math. Oh no. .42. We typically report this as a percentage Okay, so we multiply it by 100 and just take the rounded percentage. So we would actually get reported as 42. We round that number typically. Okay. So yeah, it's 42 for sand equivalent in this particular case. What's good about this is why do we like this test? Well, let's look at back at our base material. Okay, actually, let's look at the various layers in the pavement. We know the fines content for the surface layer, we'd like 8 to 15%. For the base layer, we'd like it even cleaner. If it's close to the surface, we'd like that fines down to 5%. And again, we'll allow up to about 8% if it's deep enough in the pavement. The sand equivalent needs to be at least 35 to 40 for your base materials. Because what that sand equivalent is measuring is the clay-like fraction that exists. Now, for a surface gravel, you don't want it too high because it's a measure of how does it behave? Does it hold enough water to help bind everything? Now, you could use plasticity instead, and the plasticity surprisingly matches up relatively close to the fines content, 0 to 5 and 0 to 8, until you start running a bunch of these tests. And if you've run a bunch of plasticity tests, you and I all know that you start getting plasticity down under 10, especially, it's really hard to tell them apart. It's a very nuanced test. And I could get 10 of you and pull you into a lab and we test material that's got a plasticity of 6. And some of you will say it's non-plastic. Some of you will say it has a plasticity of 10. It'll be a wide range. For low plastic materials, it's not a very sensitive test, the plastic index. Okay? So the sand equivalent is actually a more sensitive test if you've got a lot of silty materials, i.e. New York State. Okay. Now, if I'm in Texas, I'm not going to bother with the sand equivalent. The numbers are all very small. It doesn't help you much. But in a place with glacial tills, it can be a very good alternative test that's more sensitive. And why do I think that's important? Well, we did some testing. We've done testing over the years. And there's a site in Lewis County where we did some testing. And in that particular case, both of these sites, the materials are non-plastic. So by that test, you'd say, oh, these are great materials. Now, in the case of the one in Lewis County, the sand equivalent value was approximately 65. We took several samples and you get a range, but around 65. Pretty good stuff. In other words, what it really is material that's just below the sand size, pretty consistent, actually drains okay, pretty good sand equivalent. Meanwhile, we did a site down in Westchester County near the John Jay Homestead. It's actually a pretty good place to tour if you ever get a chance. And in that particular case, the sand equivalence was around 8. Okay. Now, the idea is you want a test that tells you something. There's no point in doing a plasticity index test if it's not going to help you learn a little bit. Okay. Now, there is a spec, it's spec 667, that has surface and base and sub-base gravels in it. It's a little tighter spec, though I will say I did realize when we were looking and setting things up, they've removed the sand equivalent portion from this spec. I need to work on getting that put back in because that sand equivalent is really important when you're talking with low plasticity materials as an alternative. And you may want to think about that. When I was with Yates County before I came to Cornell, I actually found somebody, that I was warned that they were sneaking the organics into our pile of material. I caught them with the sand equivalent test over lunch. And we didn't have to pay for that gravel. So now there are hand tests you can do. There's lots of hand tests. I'm a huge fan of hand tests. They don't tell you exact numbers, but they tell you when something is changed. And remember earlier I asked you when you do the gravel test, one of the best times to do a test is when things change. And so if you do an initial set of hand tests, then later on you're doing your gravel and you see something has changed, now you know it's time to sample and go to the lab. So you can do, of course, the old-fashioned clean hands test. You just take the material, you put it in your hand, and see what sticks. And if it sticks a lot, it's probably got some clays and stuff. If it's just brushes right off, it's probably mostly silts. You can hit it with a hammer. Take a small piece of metal and a small hammer and just lightly tap. And you already know how to do this. And you can see how strong that material is. You can try making a snake out of it. Yeah, it's not as scientific as the plastic index snake, but you pretty much by hand can tell materials that got more clay in them, the ones that don't. Okay. You can check the dilatancy. This is actually one I think we should all be doing. You take the material, get it pretty wet, add a little water if you need to, put it in your palm, make a ball, and then tap your hand a few times. If it's dilatant, the water will come to the surface. If it's clay, it won't. If it's silt, it will. And so if you've got dilatancy, that's a quick check to say, hey, I probably got more of a silty material, and most of the materials in New York have this. And then you take that ball of material that you've got, put it on the shelf in the sun or the dashboard of the truck, and the next day, check the dry strength. Take that little ball, half inch up to an inch max, put it between your fingers and try to break it. And if it breaks and turns into a puff ball, it's probably silt. If it doesn't break at all, or when it does break, it shatters in phases, it's probably clay. And these are some simple hand tests to see if something's changed. So if you're doing this test and everything seems to be good and it's puffing and you're like, oh, it's good, all of a sudden you start getting dry strength, maybe you've hit a different seam of material, and it's a good way to check yourself. Okay. And of course, stop, look, and listen. You've talked with the contractors, you know who's around, what materials look good, and what materials are probably want to avoid those and maybe only use them as fill. And so stop, look, and listen can be a very, very valuable thing to do. Okay. So we've talked about gravel. We want our gravel to be in that blue zone. Okay. We'd really like it to be there. That's optimum. If we had a gravel surface, it's probably a little dirtier. But we know a lot of times the material just doesn't fit. It's outside of anywhere in that hash zone, or it's in the hash, and we want to get it into the blue. So what I want to make sure we talk a little bit about how do we take those materials and get them cleaner without having to go find new sources, because that can be difficult to do. And so we're going to introduce FDR, and that's not Franklin Delano Roosevelt. It's full depth reclamation. Okay. Reclamation needs to be part of your overall treatment plan. And so, for instance, if you have asphalt surfaced roadways, it's going to be one of your options towards the end of your list. Everybody should have something in this list. Doing nothing, by the way, is my favorite repair alternative, and you're all doing it right now. And of course, drainage is pretty important. Okay. We want to try to avoid reconstruction because we know it's expensive. But we're going to talk about reclamation. And by the way, when I say recycling, I'm just talking about the bound layers on the top. I got a question in the Q&A. How would high organic material change the behavior of the materials in the hand test? First off, we don't want organics. Organics in the roadway are usually a really bad idea. We try to remove those organics or at least keep them deep if we have to go over a swamp. But organics can, over time, settle and have problems. We don't want organics. What it does, by the way, the hand test, it acts sort of like clay. But by the way, in the case of organics, you take it and you smell it. You can actually smell if it's got a strong organic component. And there are some lab tests if you've got any suspicions where essentially you heat it up in different ways. And if it has a different terms of how it degrades when you heat it up at a lower temperature versus a higher temperature, you can actually check for the organics. But yeah, we don't want to have organics. And do you get liquefaction of base material over heavy traffic? In a swampy area, you can. Okay. You can, if you've got a dirty material, you can get liquefaction. Um, but vibration is going to lead to liquefaction almost as much as the weight will. But you can get liquefaction, especially in spring thaw, when you've got a frozen layer with liquid above the top of it. Okay. So let's talk a little bit about that reclamation stuff. Oh, went the wrong way. Okay. Now I like reclamation because you have an almost new road when you're done. Okay. Because you're repairing the base. Okay. You're taking your asphalt surface, if you've got one, you're mixing it with the existing gravel to a limited depth, and you've got a new base. Okay. So it can be very cost effective. It does have limitations. It can be a challenge when you have utilities, but it really can be very effective. And the key is you're trying to turn what's there into a good gravel base or sub base, depending on what you're going to be putting on top. And so what that means is you got to pick good candidates. Okay, you got to find roads where you can stabilize it. If it's too far outside that hashed area, you can't get it into the hashed area, no matter what you do. Okay? You've got to look at the drainage. Anything we do has to include the drainage. Okay? And there are lots of different ways to make it in that blue zone. You got to choose the correct additive to get it into the blue zone or into the good base gravel zone. And remember, most of our roads started as unpaved roadways. Okay. So keep that in mind. Most of our roads started as unpaved roads. This is a road in Genesee County in the town of Pavilion from 1908. So the picture is probably 1907. So over 100, almost 120 years ago, the roadway is probably wider and it's paved. So most of our roads started out gravel. So we may need to go do some digging. Now, I'm going to show you, I'm going to ask you to raise your hand. Okay. Come on, computer, wake up. There we go. I want you to raise your hand if you think this is a good candidate for reclamation. Reclamation was not a good candidate, by the way, for crack repairs. And someone put they did a reclamation project and it worked well. Yeah, I'm a big fan if you choose good candidates. So raise your hand if you think this is a good candidate for reclamation. Okay, so a few of you have. Okay. The problem is we can't really be sure without looking what's underneath. Surface cracking like this could just be the age. It could just be an old, worn out pavement. It could even be something called syneresis. Yes, it could be what's underneath, but it's really hard to tell based only on what's on the surface. Okay, let's do the same thing again. Is this a good candidate for reclamation? What do you think? A few of more of you are probably going to raise your hands. And I don't necessarily disagree with you, but until you know what's there, yeah, somebody got it. You got to test the base. You got to know what's there to know what the quality of the material is, to choose the proper stabilizer, to see if you can even get it back into that proper zone. So you really, I'm a huge fan. You got to do a pit. Okay. You can do a core, you can do a small hole, you can even do a full test pit like we did on a project we did for our highway school for a demonstration project. One test is worth 1,000 expert opinions. And you may find the material is so far away, you can't get it into the zone. If we go back and look at our chart, if we've got a material that is, and I'm going to change colors. Let me get my color changed. I'm going to do yellow just so it shows up a little bit better. If I've got a material that is got a lot of silt and clay, it's up in the 40% range. Even adding cement, it's going to be really hard to get it all the way down into here if we're targeting the middle of that zone. Okay? Come on. There we go. Okay? And if we got a material that's got a lot of sand, okay, it's going to be really hard to bind enough of that up. And you might go, well, we could mix some rocks with it. But if you think about it, and I didn't grab my straight edge, but my phone will act as a straight edge, hopefully. If we draw a straight line between where we are and where we'd like to be, you can only add aggregates in such a way that it's on that straight line, and you can only bind up so much. So you really did need to do a test. And so the test I would always recommend is you do a sieve test and you do the sand equivalent test. You might be able to do plasticity, and let's talk about that just a little bit. So how can we do this? Well, we could pulverize what's there. This actually is very effective in a lot of cases. It's all you got to do. You got an old beat up asphalt surface, you got a dirty base, you just blend the two together. The asphalt doesn't tend to have a lot of fines after you're done, and you just blend it together, and that becomes your new base. You could bring in aggregate, and they call that mechanical stabilization, where you bring in extra aggregate and blend it all together to get the fines content where you need it to be. You can use chemicals to bind everything together. That could be calcium chloride, cement, and lime fly ash. I'll talk about those a little bit more here in a minute. Or you can use asphalt or bituminous stabilization. And that asphalt can just be a straight emulsion, or you could even foam it like you used to do with milk in elementary school where you took your straw. Same concept. And of course, a combination is very common. A lot of times, for instance, we'll add a little bit of cement to bituminous to help speed up the process. And can it be effective? Absolutely. So here's a project we did for highway school. This is the one we did the test pit, and they're doing cement stabilization. In fact, here's a picture of Lynn Irwin, he's the old director. And if you were to actually be able to look inside the reclamation machine, you've got a spinning disc that's cutting the asphalt, and there are downcut and upcut machines. And if we had time, we could talk about which is better. But the key is after it comes out of the back, you now have a stabilized material. The one thing I want you to take home in our last 7 or 8 minutes together, do not add too much. Whatever chemical you choose, whatever rock you choose, whatever you decide to add, don't add too much. The temptation is to add more. In this particular case, we were doing a cement stabilization project. They added a little bit too much cement because they didn't want to take it home. And what happened was too much cement makes it brittle. It's going to break when it shouldn't. And if you look here, I'll draw just below it. You can see a line. That line is not a shadow. That line is a crack. And what happened was the asphalt began to crack in spots, and they had to go in and fix the cracks and overlay it rather than just chip seal. And so it cost more than it should have. So don't add too much. So when you look back at your base, you again, depending where you're going to be in the pavement, is what you're trying to do. Now, in terms of choices available, well, if its fines content is, 0 to 10, usually in other words, 8 to 10, pulverize what you've already got or bring in some aggregate, you're probably going to be okay. You could probably cheat a little bit, maybe up to 12, 13% with mechanical stabilization. And when you're done, you've got a pretty good stuff. You're in the blue. But you got to check to make sure low plasticity, preferably close to 0, or better yet, sand equivalent above 35. Because remember, after you're done, it needs to meet the spec for being low plastic or high sand equivalent. You can use asphalt emulsion. Good rule of thumb is about 8 to 14% fines content. Works really well with asphalt. Again, you need at least 25 on the sand equivalents. A little higher might actually help you, but at least 25. And what happens is the asphalt doesn't cement, but it binds up the fines that are in there, the silt and the clay. But if it's got too many fines, okay, or if it's a relatively high plasticity or relatively low sand equivalent, those little fines, the really small ones, can bind up all the asphalt, and you get little globulars of asphalt, and they don't actually bind up everything else, and it becomes a mess. So again, you want to test for that. Foamed asphalt, I said 14 to 20 only because I wanted to differentiate. There's obviously overlap here. But again, you can get a little higher percentage fines content, and you are pushing it a little bit at the 20, but you need a little bit better material. Needs a little higher sand equivalent, needs to be completely non-plastic, okay? And you need to do lab tests to confirm all of this before you actually do it. You could use calcium chloride, a lot of people do, but here's the thing. When you're done, you still have those fines. The fines are still there. All you're doing is reducing the frost susceptibility, and what happens is if you've got a lot of frost, a lot of fines, you can still have problems in the spring. So be aware of that. Cement works up to 20, even some people go higher. I like to limit it at about 20% just because you can only bind so much because in economics. And then you theoretically can use lime and fly ash, but you have to have plasticity in this case. In this case, you don't want the sand equivalent because it's not as sensitive. You need plasticity above 11. A lot of materials in New York State don't have plasticities above 11. So keep these things in mind. And again, if we had longer, we could talk all about stabilizer selection for reclamation, but that's a different webinar. Okay, so what we're going to do is we're going to do our ending with some PDH questions and hopefully get you thinking. So let me just ask, first off, good gravel, surface gravel makes a good gravel base. Is that true or is that false? Very good. Yes. Okay. Yeah, that's false. If you've got a good gravel surface, it's probably got a little bit more fines in it. It's not too dusty, but it's not too, it doesn't get too soft in the spring. So it's really false. Yeah, and if you need to, you can put it in the Q&A. So you have false. In this case, remember, that's what happened. They chip sealed over a road that was a good gravel surface, and it failed because the water couldn't get through the asphalt and it blew it apart. What's an alternative to the plasticity index test? What's an alternative? Should say plastic index. I apologize. But Sand equivalent. Yeah. And yeah, it's not the sand equivalency, it's a sand equivalent, but it's essentially a ratio. It's the old mason jar test done in a scientific format. Okay. And again, it's one of our favorite tests that we think could be used by people. FDR stabilizer can be chosen from a surface analysis only. Is that true or false? Ooh, got a little bit more challenging here. You can look at rows and probably know, because if you know their history, you can probably go, it might be a good candidate. But until you actually do a test pit to know what you've got underneath, you really can't make a final determination of if it is a candidate, and better yet, what stabilizer to use. You need to do a test, a test pit, something to get base gravel and figure out what you're going to have after you get it mixed. Okay? So those are our PDH questions. Um, we are just about done with this webinar. Next week, we will do managing the fleet through July. We got a whole bunch of very good webinars. Yeah, they're not PDH worthy, but they're really pretty important stuff, especially if you've got employee issues or you want to be ready for emergencies or communication. But we know PDH tends to draw the people in. Any questions from anybody? You can throw them in the Q&A. We can answer any last questions people have. Looks like they're going to let me off the hook today, Amanda and Jody. Okay. Well, with that, I will say thank you. If you have any follow-up questions, please just send us an email. You can send it directly to me, david.orr@cornell.edu, or just our general address. All the links are available in the handout, and you can go to our website and download these materials as well. Everybody have a great day. Please stay cool. We're talking temperatures in the 90s and even the hundreds for the next few days. And we'll see you soon on one of our foundational webinars. Take care. Happy holidays. Happy Independence Day. Bye-bye.